Today we'll be looking at how to add and subtract vectors. So we'll first start by looking at adding vectors, and we're going to look at adding just the components, so the column vectors, and also adding our directed line segments. So this first example, we're just going to look at the components, so our column vectors. So we've got vector A, which is 5, 3, and then vector B, 3, negative 2. And if we were to add these together, we have A plus B, and we're simply adding the relevant, same components. So we're going to add our X component, so 5 plus 3 gives us 8, and then our Y components, 3 subtract 2 gives us 1. And that is how we add our column vectors. And we can also add using our directed line segments. So for instance, if I was to draw out our vector A, 5 and then 3, meaning we're going along 5 and then up 3 to give us this. And remember that important arrow giving us the direction. So we're going along 5 and then up 3. And when we are adding our directed line segment, so I'm going to add on vector B, we add it to the end of where we finished drawing. So we've started drawing from this side of vector A, and we've got to this end, the arrow is going in this direction, and we're going to start drawing from this point right at the very end. And from this point, we're going to draw 3, negative 2, meaning we're going along 3, down 2 until this point here, and then we join them up to get vector B. But our final vector, okay, so we've added them together, but the final answer needs to be represented as A plus B, okay? And we can think of this as a little journey that we're taking. So we've started down at this point here, and we've travelled along A, and then we've travelled down B. So we've started from this point, and we've ended up over here, so we can draw a straight line to join them together. Okay, and this vector here, that is our vector A plus B. Okay, and we can see that it has the same components because we're going 8 along and 1 up. And this final vector here, this is what we call the resultant vector. So if you're ever asked to find the resultant vector, that means we're going to be adding our vectors together. And you must remember to draw the final line, the final vector joining your little journey together. And it's super important that you put in this vector direction because we've started at this end and we've ended up over here. And this is our vector A plus B. Okay, so I've said that this could be your turn. So feel free to pause here, and I would like you to draw the representative, so the directed line segments of C plus D, and then also stating the components of C plus D, meaning that you're just going to add them together numerically. So if you're not 100% confident just yet, if you just hold on and we'll go through the solutions together. But if you want to have a go, you can pause here. Okay, so let's begin by first drawing the representative of C plus D. So we're first going to start by sketching out C, which means we're going along 2 and up 3. So along 2, up 3, and we've got our direction going in that direction. And then from the end of C, so we've finished drawing here, so we're going to start drawing from this point, and we're going to go along 4 and down 1 because we've got negative 1 for our Y component of our D vector. So we're going to go along 4, starting from this point, along 4, down 1 to finish here, and that's where our D vector is going to go, and we're going in this direction. And remember, we need to draw our resultant vector, so our little journey is starting at this point and it's finishing up here, meaning our vector C plus D looks like this, and that's the direction it's going in. So we're starting from down here and ending up here. What's nice about these is we can either calculate your components just by adding together, or if you're confident naming the components from your vector, you can see that we're going along 1, 2, 3, 4, 5, 6, and then up 2. So our components are going to be 6, 2. And then we can see if we were to add them together, 2 plus 4 is 6, and then 3 subtract 1 is 2. So that means we know that we've got this question right because we've worked that out, and we can clearly see our components is represented in the same as our directed line segment. Okay, let's, yes, and this is our resultant vector. So again, if you're ever asked to work out the resultant vector, you're going to be adding the components together. And especially if you are to draw the resultant vector, make sure that you've got your little journey C, D. You're starting from the beginning and you're finishing at the end. Join them together, and you must include the direction of the vector. Okay, let's look at a second example. So again, we're going to draw a representative of P plus Q, and then we're going to state the components of P plus Q. So we have vector P, which is 2, 4. So we're going to go along 2 and up 4. So starting over here, along 2, up 4, and then starting drawing from the end of P, because that's starting our little vector journey. From the end of P, we're going to draw our vector Q. So we're going back 3 and then up 1. So back 3, up 1 to get to this point, and then we're going to join them up, and we've got our direction in there. And then to draw that resultant vector, remember our little journey starts down here, and we're finishing up here, going in that direction. That means our vector P plus Q looks like this. And again, you can read off the components from our diagram, or you can work it out by adding them together. So 2 add negative 3 is negative 1, and then 4 add 1 is 5. Meaning our resultant vector P plus Q is negative 1, 5. And again, we can check this because our resultant vector that we've drawn is going back 1 and up 5. Okay, if you could pause the video here and give this one a go. Okay, so we're going to begin by drawing out our little vector journey that we're going on. So we're going to start to draw vector G, which is 5, 3. So we're going along 5, up 3. Okay, along 5, up 3. We're going to start drawing our vector H from this point here, and we're going back 4 and then down 1. Okay, so back 4, down 1 to get to here. And then we're going to draw our resultant vector. We've started drawing vector G from this point. We've finished up here, so we're going to draw a line, joining these together and going in that direction. And that is our vector GH. Our second part of our question, we have to state the components of G plus H. So G plus H, either read off from the diagram, we're going along 1, up 2, or you can add these both together to get, that should say GH. To get 5, negative 1, negative 4 is 1, and then 3, negative 1 is 2. So this should say G plus H. Okay, this last example on adding vectors. The vector S, so that's represented as 6, 3 in a column vector, represents the sail velocity of a boat. The wind velocity is given by W, vector W, which is 5, 0 as a column vector. Both forces work together to create a resultant vector force. So the resultant vector, meaning we are going to add. Calculate the resultant vector, and to do this, we have to add our vectors together. So S plus W, that's how we find resultant vectors, by adding them. And then we just take our two column vectors, add together the same components. So 6 plus 5 is 11, 3 plus 0 is 3. And that is our resultant vector. Okay, so we've looked at adding vectors. We're now going to consider subtracting vectors. So we can think of subtraction of two vectors as, so A subtract B. But we can think of it as A add the negative of vector B. So for example, suppose vector A was 4, 4, and b was negative 2, 3. If I was to sketch these out, so I've got vector A, which is 4 along and 4 up. I've got vector B, which is back 2, up 3. But then remember the negative of that vector is this. Okay, so it's the same angle, but it's just the complete opposite direction. So then the components for vector B would be, you would change the sign, so that would be positive 2 and that would be negative 3. So we're going along 2, down 3, along 2, down 3. So they're parallel to each other, but they're just going in the opposite direction. So we could work out A subtract B, but when we're drawing it, it's good to consider you're adding on to the end of your vector A, you're going to be adding on negative B when you're subtracting. So what does that look like? So if we've got vector A, and then we are taking them away, we're subtracting, we're adding on the negative of B, meaning at the end of where we have drawn, we're then going to draw our negative B component, which looks like this. And remember to draw your resultant vector. So we're starting from A, finishing over here, and that is our direction. Because if you were to draw A and then add on B, you would end up going all the way up in this direction. But we're adding the negative of it, so it's the same parallel direction, but we're just parallel, but we're going in the opposite direction. And then we can state the components of AB. So 4 subtract negative 2 is 4 add 2 to get 6, and 4 subtract 3 is 1. So be careful of your double negatives when you're doing this. Okay, second example. We have to draw our directed line segments, so our resultant vector of C subtract D, and then also stating the components of C subtract D. So to do this, we're going to start by writing down our negative D vector. So the negative of D, we're just swapping our signs around. So this was negative 5, it becomes plus 5. This is positive 1, it becomes negative 1. So we're going to start by drawing out C, and then we're going to add on our negative D. So we're going to subtract D by going along 5 and then down 1. So this direction, and remember we must draw on our resultant vector. So starting our little journey from this side, ending up over here, and that's the direction we're going in. So you can either sketch it out and read off the components. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 along and 2 up, or you can subtract them. So 4 subtract negative 5 means 4 add 5 to give us 9, and then 3 subtract 1 is 2, which is what we have. Okay, let's look at this third example, and then I would like you to try this one once we've spoke through this first example. So we're drawing the representative, so the directed line segments again, and the resultant vector of P subtract Q, and then we're going to state our components. So let's start by finding the negative of Q. So swapping out our signs, negative 2 becomes plus 2, 1 becomes negative 1. Start by drawing out vector P, so we're going 4 along and 3 up. And at the end of vector P, where we've stopped drawing, we're going to draw the negative Q, so we're going along 2, down 1, going in this direction, and remember we need that resultant vector to start the start of our journey, at the end of our journey, and we need our direction. And you must label your vectors as well, so this vector was P minus Q. Once we have that, we can either subtract the component vectors to find our components of our P subtract Q. So 4 subtract negative 2 means 4 add 2 will give us 6, and 3 subtract 1 will give us 2. So P subtract Q is 6, 2. And we can double check on our diagram, we're going along 6 and up 2. So if you could pause the video here, and can you please try this question? Okay, so let's begin by, we know we're subtracting, so we're going to A subtract B. We're going to add on the negative of B, so let's first write down what the negative of B is. Swapping out our signs, so we've got negative 7 becomes plus 7, 1 becomes negative 1. We're then going to start by drawing our vector A, and then adding on our negative vector B. So vector A is going back 4, up 4, and our negative B is going to go along 7, down 1 to here. So we're going to join them on. So remember, drawing from where you finished drawing vector A, add on vector B, and our last step is to draw on our resultant vector. So our journey started here, we ended up over here, going in that direction and labelling your vector as well. And our final step was to state the components of A subtract B. Either read off from your diagram if you have it. So we're going along 3, up 3, to give us 3, 3, or we can simply subtract what we have. So we have negative 4 subtract negative 7, which becomes negative 4 add 7 to give us 3, and then 4 subtract 1 is 3. So well done if you got that.